Hello and welcome to the Anatomy of a Minecraft Model, lecture number 2, animations. So the last time we took a look on how we can set up a simple model. It was a bit boring, but it still worked. We had different model renderers with model boxes and so on, and we got this little floating droid that didn't really do much, but still it had a model which, well, kind of worked, I think. But like I said, it was a bit boring. Let's see if we can make it animate. I'm not going to animate its current parts, but I'm going to add more parts to it, and we'll see how we can make those animate to, well, basically make this model here a bit more dynamic. So let's get going, shall we? So I'm just going to head over here to the model droid, and what I want to start with is adding something that will be spinning inside here. And well, to start with, we need to add it normally. So we don't have to do anything different to start with. So I'm just going to do model render like so, and call it core. Okay. And then what I want to do is create a new model renderer, this 30. Okay, so that's where in the text file I want to refer to it, if you remember. So we can see this is a sort of summary of what we learned last time as well. To freshen up your memory a bit. So just where we, well, get it from the texture file there. Then the next part is obviously to add a box to it. And well, I'm going to use the negative half rule here completely. And what I want is the size, if I can get that on a new line, sorry. And the size I want is 6, 2, and 6. There you go. And the negative half rule gives me -3, -1, -3, like so. So that's just a simple box. It's 6 by 6, like its base area, and then it's 2 pixels high. And that's everything for the core. But the core here, what is this? Well, what I want to do is to put it inside the, well, in between the pillars. You know, we have a little space there. If you remember from last time, we had pillars and then we had something on the top there, sort of forming some sort of helmet, maybe. I'm going to call it helmet later on. So in there I want a core of this droid, so the core of the droid, and as we can see, the height here is 2, and if we take a look on the pillars themselves, their height is also 2, and they are spaced so we can fit a 6 by 6 block in between them, in the middle. So that's basically what it is, and therefore, since we set pillars position there to -6, what I want to do is do the same here. So core dot set rotation point 0, -6, and finally 0 again. So that's just where this core is going to be located. And finally we do side, I'm reading the wrong part of my notes, parts dot add, like that. So we just add the core to the list of parts, so it's going to be rendered like so. We can take a quick look on that as soon as we have made a texture for it. So here's the texture sheet from before, but since I specified 30, where we want this new texture to be is up here. That's just where I told it to be, and therefore we'll have to put it there. So here's what we're going to do here. 1 pixel, 2 pixels, 3, 4, 5, 6, like so. So this is supposed to be 6 pixels. What I want to do is just grab like a green color here. And if you remember, we want the first square there to be blank, then we want that to be filled there, and finally that one to be filled there as well. And since we just have 2 pixels high, what we want to do is obviously have a 2 pixels high little thing in there. So I'm just going to fill these ones up like this. Like so. And just to make sure that this is the correct size, what I'm going to do is select that area, and oh yeah, 6 by 6. Nice. There you go. Pretty much it. But well, just for the sake of it, let's add some noise here, just to make it a bit more scrambled, I guess. There you go. So now I've saved it, and there we go. Let's take a look on how it looks like for now. Obviously, it's not being animated at all, but what I want to do later on is to make it spin. It should spin around itself. We'll take a look on that as soon as we see where it's being placed, if it's being placed properly. There you go. So now we have that little core thingy there in the middle there. So all of a sudden, well, we have something in it that is not gray. That's marvelous, right? But yeah, for now I'm going to make it spin. And for now, when we work with animations, we might want to see how things move properly. So just during testing phase, I'm going to disable its movement, so it's not going to move anything. We're going to enable that in the end to see the result. But when we're developing this, it might be a good idea to make them well, completely still, so they won't just move around all the time, so we can see the animations better to make sure that they work. Okay, so now we have that. How do we make it rotate? Well, we've seen how we can rotate things before, and that's totally how we're going to do it, but in a bit of a different way. We take it with a different angle, I guess. So we want to set the rotation angle, and here we want to set the rotation angle Y, because we want to rotate it sort of in a similar way that we did with the side, that it actually goes around with the base is sort of spinning around. And we're not going to flip it or roll it or whatnot, but spin like that. So it's the Y we want to change, but we can't just change it here. Like core dot rotate angle Y equals like math dot pi divided by 4 or something like that. That's not going to work. First of all, this is a double, but more importantly, we're going to just set that once. It's not going to animate, but just because we rotate it once, that's just going to give it another rotation. So what we want to do is head up over here, private model renderer core. So I'm going to add the core up there instead, if I can spell, that is. There we go. And then what I want to do is remove that part. So what's the difference? Well, instead of having a local variable called core that I create here and add it to parts, what I have now is a field here called core, and then I just, well, create a model renderer anyways and store that in core. And the reason is because then we can head over to the rendering code and update the core's angle there. Therefore, we're going to update it just before we render it, and therefore it's going to get well, the rotation that was set at the very moment there. So the trick here is to set it to different things, right? But we can't really do something like this. Private float test, and then we just do that equals to test, and then test plus equals to 0.1f. First of all, we shouldn't name it test, but you know, this is not what we're going to do. The reason why is because we have this model here, this model droid, that is being used by all entities, all entity droids. It's not just being used by one. We have one single model, and that's used by them all. So therefore, if we just updated it here, then all the droids would update the rotation, and then, well, we wouldn't really be able to control things properly, because each time we rendered it, it would modify the value, and therefore it would spin faster and faster the more droids we had in view for the player. And that seems very weird. That's not how it's supposed to be. So what we want to do is we're going to ask the entity about the rotation we want. So the entity itself, the droid itself, is going to keep track of this rotation here. So what we want to do is, well, we can do it like this. We can do entity droid equals entity droid, like that. Import the entity droid, there we go. Now we can just refer to the droid. What I want to do here is get core rotation. So we want to ask the entity which rotation should the core have. Should it be like 90 degrees, 180 degrees, you know, even though we're not going to use degrees, you're going to use radians. And as I said before, if you don't know radians, then I suggest you to read up on that. You don't really need to know much to be able to follow along. But I'm also going to convert that to degrees when I'm talking about it, so you might be able to stick around anyways. Okay, so we want to return this here. So what should we return? Well, I'm just going to return core rotation like that. So that's obviously going to be a field, so I'm adding it here. So observe now that I'm in the entity. So the entity is going to control its rotation. That seems to make sense. Private float core rotation. And I could of course handle this on the server side, and the server tool decline and so on, but in many cases there's no reason to. if there's something specific that has to be synchronized and we have to save the rotation when with server loads and so on, then we might have to put it on the server side as well and then synchronize the client. But for now, we just want the core to spin. There's nothing important if all of a sudden we have to relog and then, alright, we lost 3 degrees in the spinning just because, well, we didn't say where we were and so on. So it doesn't really matter in this specific case, and therefore we handle everything on the client side. So as you can see here, if we are on the server, we want to update the motions like we did last time, but otherwise that means that we are on the client side, then we want to do core rotation plus equals 0.05. So I think that's good. That's quite a small value, but each time it ticks, we're going to increase it like this. And the good part here is, well, not only how do we have a value that is unique for every droid, or well, they can be the same anyways, but they are controlled by every droid, so that means that it won't rotate faster just because we have multiple droids. But also, the rendering code here, we can render something a lot of times. If we have 300 FPS, then we're going to render it 300 times, right? Each second. And that means if we would update it here, we would, well, update the rotation 300 times in just a second. Even though if you had 20 frames per second, then we just update it 20 times. This means that it would spin in different speeds. And that's not what we want, really. Well, maybe that's what we want, but it seems like a very weird. So that's another thing that is good with storing it in the entity itself. Now we know that each tick we're going to update it like that. Of course, you can have lag and the tick rate might be a little bit low, but it's more reliable than the FPS, because the FPS is not supposed to be a specific value. The FPS is supposed to be on a high value, depending on, well, depending a bit on what your system can handle and so on. But the tick rate is supposed to be 20 ticks a second, and then of course it might be a bit lower if you can't keep up. But so that's two good things. First of all, it doesn't depend on the amount of droids we can see, and it doesn't depend on the FPS, and we can control it much better as well. So let's start and take a look on this first animation. Right. There you go. As you can see, as you can also see, they are completely still, and that's just because I disabled that in the code for now, so we don't have to bother about them moving up and down when we take a look on how the animation works. Because I want to describe how specific animations work, and then it's easy if I don't have to move along. But we're going to enable that in the end to see how the end result is. And there we go. It's just spinning around its own axis like that. And the reason why it spins around its own axis is, of course, what we've been discussing before, and that is the negative half rule. If we have a negative half rule, what that means is that the center of the box is going to be at 0, 0, 0. And by 0, 0, 0, I mean 0, 0, 0 of the model renderer. Then that we move the model renderer up a bit doesn't really matter, because it's the model renderer that we rotate, and therefore the box, which is a part of the model renderer, is going to spin, and that's going to spin around the model renderer. And having them at the same location means that it's going to rotate around its own axis. There we go. Very simple. Just make it spin like that. So it has some sort of green core there that is spinning around like that. And it doesn't matter how many times we render this, it's still going to rotate at the same speed. If we wanted to rotate faster, then just increase this value with something higher. If we want to decrease it, well, rotate slower, then just increase it by a smaller amount. I don't know what's going on with that tower there. They are having fun. Right, so that's the first thing. Now we can rotate all of those cores. Okay, so what's the next step? Well, we're going to take a look on something that is going to be awesome when it comes to animations, and that is child model renderers. So what's that? Well, we'll take a look in just a second. And what I want here is a model renderer panel equals new model renderer this. 1834. As you can see now, I'm actually defining this inside a loop. So we're going to do this 4 times. You know, we have put the 4 sides on the droid, so we have one of these little signs, these little plates on each and every side of the droid itself, and that's going to work because, well, we have set it to 0, 0 here, 0 here, but we rotate it like that, and then we put the box with 5 off like that. So that's how we added this side. But how are we going to do with the panel? Should we do the same thing? Because what do I want with this panel? Well, I want it to attach to the side. You know, these little plates here. I want to put another plate just connected to it, okay? So we sort of get a double plate, if you wished, a double side. So we need to do something similar, right? So we put it right at the edge there. Okay, so one could think that, well, I'm just going to add the similar box, right? Because we want sort of the same thing to be added there. Well, 8, 5, oops, and 1, there we go. So it's going to be the same size. But am I going to use the same coordinates here? Well, not really. Negative half rule. Negative half rule. Not negative half rule. Okay, so this seems like a bit weird because we wanted to put it in the same sense that we did with the side, right? And I've done the wrong thing here. It should say panel. So it doesn't really seem to make sense. I should put it at like 6 here or something like that, so it gets 1 pixel further out, so it gets attached there. But for some reason I added it to minus 0.5, and I'm also giving it this thing there. It doesn't really make any sense. But you'll see in just a second what's going on here. Okay, so then I'll do panel dot set rotation point 0 minus 2 6.5. This doesn't make any sense either. Like, what is this? Well, first of all, it's not a double, well, a float there. So what we're going to do here is set the rotation point with sort of what we wanted up here. I said we wanted 6 here, but now we're using 6.5 here in the rotation point. But we saw last time, if we set it in the rotation point and then rotated it like panel dot rotate angle y equals r, what we would see now would be that the I spelled it wrong. We would see that, well, that panel there would just rotate around itself. It wouldn't move to the different sides. So it's a bit silly to do something like this, right? Like, what's the point in doing it? It's just going to go wrong. We discussed this last time. It's not going to work. But if you don't know what I'm getting at here, you might have forgotten about what I mentioned a few minutes ago. Child model renderers. So we're not going to rotate the panel. We're going to do side.add child panel. And what this is going to mean is that if we do anything to this side, then that is going to affect the panel. And last time I said that, well, when we rotate the side like this, what we did was to, well, rotate everything contained around it, okay? So we rotate this box around it and move that box depending on where it were and so on. But I said that, for instance, a box, and it can have different childs than just boxes. So the boxes will rotate around it when we set its rotation, but we also rotate the child model renderers. So what's going to happen is that since we have set it to 6.5 here, that one is going to rotate in the same sense that this box is. And then you might say, alright, but we shouldn't do it in the model renderer because, you know, we had a problem there when it rotated around itself. The problem is not that we do it in the model renderer. The problem were that we did it with the one that was rotating. The side is the one rotating. The panel, the child there, is just following along in the rotation in the same way the box is. So the box is following along in the rotation, yes, because it is 5 pixels out, and therefore when we rotate it, then it's going to rotate with it will always be 5 pixels away from the center, and therefore it's going to go around the entity itself. And that's going to be the same thing for this child here, the panel. That's a bit further out, 6.5, and therefore that's also going to go in a circle around, just because it's a child of this side, and this side is being rotated. So that's going to mean that it's going to follow along and be placed properly. And then we're going to place the box of the panel sort of at the same position as the panel. We see some weird things going on in the Y value here, and that's why we have -2 here to cover that up to make it work properly. We'll take a look exactly why I don't do -2.5 there and 0 here. We're going to take a look on that. So now you may think, alright, this next part is parts.add panel. We need that to be rendered, but no, this is completely wrong. We shouldn't do that. Don't do it like that. If we do, what's going to happen is we're going to loop through it in the end here, like so, and render all the parts. And isn't that what we want? Well, that is what we want, but when we render a model, what we're going to do is render all the boxes of the model, and we're going to render all the child model renderers of it as well. And that's going to mean that because we render the side, that we automatically is going to render the panel. So if we add the panel to the list of parts, we're going to render it once when we render the side, and twice because we're also rendering it on its own here. So we shouldn't add it, but just because it's a child model to something we already render like that. There you go. So that's the first step here. The next step is obviously to add its texture, and if you remember, what I set it to was 18, and that's 18. Well, if I can select it properly, and this is 34. So we should just start adding it here, like so. But what I want to do here is the following. I want to let's see. I want to grab the. It has the same size as this one, so I can just use this as a easy way of making a selection there. So I have the selection there, and that's going to be the same color, somewhat, as that one. There we go. So that's going to be most of the sides, and the last side, you might have seen this coming. But what I'm going to do is, it's not going to be just any panel. It's going to be a solar panel, and I'm not going to have too much time just picking the correct colors here. So I'm just going to take some colors here and hope it works good. There we go. So this is the front of it, like that. And now I'm going to have another color in between there. So this is the style of solar panels that I use in Steve's cards, and Steve's cards too. But yeah, it's just a texture after all, and I'm not going to spend a lot of time doing it because it doesn't really matter in this example. But just to have something there, very simple, a bit weird colors, maybe a bit too bright, but it's totally fine. There you go. Save it. Okay, let's take a look. Oops. Right, there you go. So as we can see now, what we have here is, we can actually see that we have two different blocks. If you look closely, you can see two different colors, and that's just because, well, they aren't really the same color. I didn't really make them exactly the same color, so we can see sort of a very small difference there. But we also have noise, so it's not really possible to tell, but we know it's two different parts there. So we have the inner part, which is 1 pixel wide there, and then we have the outer part. And the reason why they are put properly is, well, the following. We take a look in the code. So we have this one at 5 pixels, right? 5 pixels of the center. This is 6.5 pixels of the center. Wouldn't that mean that it would be half a pixel too far out, because we want a 1 pixel difference? But what we want to do here is, well, use the negative half rule, and therefore we in the end get 6.5 minus 0.5, and therefore we get 6, and 6 is 1 more than 5. But the reason why we put it in here is obviously because when we rotate the side here, then it's going to affect the panel. So that's why we can put it in here, whereas here we put it in the box there, like so. So they are being put there, and we don't have to bother about the rotation. The panel there is not rotating itself. It's just following along as the you know, the side is rotating. The side has been rotated to the proper side. Sounds a bit weird, I know. But then we have the panel just following along because it's a child model there. Okay, so what do we want to do next? Well, you know, panels, they're all nice there, but shouldn't they extract so they face upwards to the sun when the sun is up, and then retract again when it gets dark? This is an animation lecture anyways, so that's exactly what I'm going to do. I'm going to make the panels extract in the sun and retract other one. Okay. So how do we do this? Well, I've actually prepared most of those things, and I don't mean prepared by having a lot of code prepared that I'm going to paste here. I've actually already done the trick. Okay, is that a negative half rule? No, it's not. But if we sum these together, -2 minus 0.5, we get -2.5, which is the negative half of 5. That means that in the end we're going to place it properly. It's going to be located in the same position that the box itself, well, the side box is. So that's why we saw them at the same y value. But by doing it like this, I split it up in -0.5 and -2 there. What we're doing is, well, we're placing it in the correct position, but the rotation point is going to be 2 pixels further up than what we might expect, than the center. And what that means is that the box is just half a pixel on top of the it starts just a half a pixel further up than the actual rotation point. And this is going to be very important when we do the extraction of the panel, because then the point we are rotating against is the top of the panel. And that means we can, when we rotate it, it's going to rotate outwards and up rather than just spin around itself. Because if it would spin it around itself only, then the top part of it would obviously go towards the center of the droid and just be hidden inside it. We'll take a further look when the code is ready so we can actually see that in action. So what I want to do is first of all be able to modify these rotations, and to do so I'm going to do a similar sense that I did here. But well, now we have multiple ones. We have multiple panels, obviously one for each side. So what we want to do here is private array list model renderer, and then it's just a matter of calling it panels, if I can spell. There you go. Like that. And then it's just a matter of creating the panels here. Panels equals new array list model renderer, like so. And what we want to do here is simply panels.add panels. So now we have an array list of all of those. Observe that we still don't add them to the parts list here, because the parts are the ones we want to, well, render basically. But child models will be rendered automatically when we render their parents, so therefore we shouldn't render them directly, because then we would render them multiple times. Once in the normal way and once when we do it through the parent model renderer. But, well, what are we supposed to do now? Well, we have this part here when we update the core rotation, and we're going to do exactly the same thing, but for the panels, and all the panels will have the same rotation. Well, is that true? Well, they're going to rotate, right? They're going to extract in some sense and reach their upper position. But since they are child models to the sides, they do not know themselves their side they are on the entity, which means that their rotation doesn't matter when it comes to their side. We can just think of, alright, you're going to extract in this sense, we're going to actually change the X rotation, and that's everything we have to keep in mind. And that's the good part. We don't have to bother about on which side it is, just because that is handled in the parent model renderer, and that's pretty awesome. We'll take a further look on that when we actually have the code finished. Model renderer like so, and then we do panels, and finally it's just a matter of doing a panel dot rotate angle X. I said we would use X, and that's just because we're going to modify the Y value and the and the C value. So we're not going to do anything with the X, you know, that's the wide part there. It's not going to like flip that one, it's still going to be in its proper location there. It's not going to update that value, and that's why we want to rotate it. So when we wanted to rotate the core, we had a 6 by 6, like so. We didn't do anything with the Y value, right? It didn't like flip upside down and anything like that. It just spin around itself. The base itself span like that, and therefore we want to rotate Y. So we sort of rotate the dimension we don't want to change, and that's why we rotate X here. And that should be the same as droid.getPanel rotation, like that. And obviously that doesn't exist either, but that's what we're going to create. So create method get panel rotation in type entity droid, like so. Nice. And I'm going to do the same thing here, return panel rotation, and that's going to be a field up here, obviously. There you go. And now we might think, alright, maybe we should have the panels controlled by the server, so the server can just tell us, right, we just loaded the world and you should be in your you know, in your well, extracted position when you have the solar panels already facing the sun, because that was what you had when we well, unloaded the world. So now you should start in that position. Yeah, maybe that's true, but I'm not going to bother about that. What I'm going to do is just, well, if you start the world again, they will just extract again. And depending on what we want to do with them, that might be wrong or it might be alright. And I'm going to do it that way, so we don't have to synchronize all of that. But we still need to synchronize something. And the reason we have to do that is because the light level in a world, well, it's synchronized to the client so we can render it properly, but we can't really reach it properly. We might get like wrong values. It might say, alright, the value here is completely wrong. Yes, because it's night, it maybe didn't update and so on. So what I'm going to do is ask the server, can you get us the value? And then it's going to tell the client if it's going to be bright enough to open the panels or dark enough, and then retract the panels again. So that's what I'm going to do, and we're going to use data watchers for that. So what I want to do is data watcher dot add object. I'm going to use ID 20, it doesn't really matter, and finally the value 0 is fine. There you go. So that's just when we create it, but the important part comes here when we update. So the server is going to update the data watcher if it goes too dark or too bright, so it's going to change the state, and then the client is going to use that. Okay, I'm just going to take a look there. There we go. Sorry. So what I want to do is boolean light. So that's as if it's going to be bright enough. World ob dot get block light value, and then we want to get the integer position. Oh, come on, integer position of it, so we can refer to the block there. And we could make sure that like we can see the sky as well, and you can ask the world like, alright, can this block see the sky, is there anything in the way, and so on. But I'm not going to bother about that at the moment. I'm just going to say, is it bright enough? If so, then alright, then it's fine. So we get the boolean here, is the light value 15 or not? So that's there. And then what we want to do is simply data watcher dot update object, like that. Use 20 because that's the ID we used before, and then if the light level is bright enough, then we want to get the byte 1, otherwise we want the byte 0. And well, we could synchronize the rotation as well, just tell the client you should use this rotation, but I think that's a bit too much. So the only thing here, we're going to synchronize if it's, well, bright enough or if it's not. And the good thing with data watchers, if we, as you can see, we're updating it each time. Each time we update, we're going to update it here. But the good thing with data watchers is that they make sure that we actually have a new value. If the value we set it to is the same as the old value, it's not going to update. It's not going to synchronize that to the client, and that's perfect, because then we can just do it like this, and we don't have to bother, alright, is this a new value or not? Should we send it? Should we just ignore that? So we just send if it's 1 or 0 depending on the light. So we will synchronize if the light changes. Okay, now we are on the client side. Now we should update the panel itself. If data watcher dot get watchable object byte, and then if we get the 21, sorry, that's the ID we have been using, and if that is not equal to 0, that means that, well, it's bright enough, obviously, and otherwise it is too dark. And if it's bright enough, we want the panels to extract. If it's dark enough, well, too dark rather, we want them to retract again and go back to their initial state. And we can do that in a similar way to how we did with the core rotation, but now we want them to stop at a specific angle. So what I'm going to do here is simply math.min, I'll talk you through this in just a second, float math.pi divided by 2, panel rotation plus 0, 0, 2f. There we go. And Eclipse is just being a mean. There you go. So what we have here is that the new panel rotation, when we want to extract the panels, is going to be panel rotation plus 0, 0, 2. So we're increasing that. However, if we have this value is set to math.pi divided by 2. So if this value here, the value that we get, is getting bigger than math.pi divided by 2, and that's the same as 90 degrees. So if it does that, then the minimum value is going to be math.pi divided by 2, and therefore that's the value we're going to use. However, if we haven't reached that point already, like the panel rotation plus 0, 0, 2, it hasn't reached math.pi divided by 2, so we're not in our completely extracted state yet, then this is obviously going to be the minimum value, because like I just said, we haven't reached that point yet, and therefore that value is going to be used. So here we're just making sure that we're not going to go too far. We're not going to go beyond the upper bound angle. I don't know what to call it, but the extracted state angle there. And then we want to do a similar thing when we rotate it back. So here is the code for when we want to retract it again, and what we want to do is math.max this time, and 0, and then panel rotation minus 0.02f, like that. And this is the same sense that we have before. So, well, we're going to set it to 0.02, sorry, less than before. So we have panel rotation minus 0.02, and that's going to be set here. However, if we go below 0, then all of a sudden 0 is going to be the maximum value of these two, and that's going to make us stop there. However, if we haven't got to a completely retracted point where they just go straight down, then what's happening is that the panel rotation minus 0.02 is greater than 0, and therefore that's the maximum value, and therefore the value we will use. So we're using min and max here to make sure that it won't go beyond the angles it should be within. So let's take a look on this. Right. Look at that. Look at that. Boom. So if we set it to night again, it's going to time set night. There you go. And it's going to go down there again, like so. And that's why I prepared these ones, so we can see it properly. So let's take a look on this dude here. If we look at the very point that I'm looking at, let's see if we can get it properly. The very point the cursor is on now. If we take a look on that specific point, take a look on it. Can you see if it moves when I set it today? Take a look on that one. Does it move? No, it's not. It's completely fixed. Maybe I'm looking at like a tiny bit wrong, but you see the position right there. It's not moving. Times at night, it's not moving, and that's the whole point. That's our rotation point. The rotation point is, well, what we have there is not moving itself, and we can take a look in the code. That's the whole point here. If we go up here to the panel itself, what we have here is minus 0.5 and minus 0.5 in both those dimensions. here in this dimension we have it because it's the negative half rule, and that's because, well, we have the panel here is 1 pixels wide, or 1 pixel whatever, so we have 1 pixel there from that upper edge there to the lower one. That's just 1 pixel. But what we want to do is have, well, then it's the negative half rule, so we have it in the center, but we do want to have it like that no matter in which of the states we have, and therefore we don't want the other one, the y value one, to be in here. That would be negative half rule to put it in there, but we want it to be here, so I can't move properly. So we want it to be there no matter what. That means that when we go into the lower state, if we set night like so, then it's going to keep it there, and we rotate it like that. We have half a pixel upwards, up to the edge there, we have half a pixel, but when we have rotated it like this, we also have half a pixel to the right there. Yes, because the y position is set like it is, like that. And the reason why I have half a pixel is so it's going to fit with the height of the negative half rule that we have from this one here. So by putting it like that, with half a pixel off there in the top there, we're going to make sure that it's being rotated properly, and that rotation point is kept in the same location. If we would just use 0, 0, and so we had it up here, then we will see that it would, when it retracted here, it would go and get stuck inside the whole thing, and when we got it up here, it would be put on top. So by putting the rotation point just half a pixel off there in both those two dimensions, it doesn't matter which state it is, and therefore we can just rotate it back and forth like this, and it's working like so. But of course, if we don't use the negative half rule, we have to keep in mind that we might want to move it, and that's what we're doing here, because here we have it at minus 2.5. That's the side, that's the thing that is not moving, and therefore what we want to do is make sure that we get minus 2.5 here as well, and that's what we have here when we add these two together like that. And the result is this thing that we've seen a few times that day, and it's working no matter which side we're looking at. Yes, because the panel itself is not bothering about its rotation on the droid. That's the side, the inner part here, that is keeping track of that, and therefore we don't have to do that. In the fourth course, the fourth lecture, we'll take a look on 3D modeling softwares like Techni, for instance, which is a very famous modeling tool for Minecraft. It's specifically developed to work with Minecraft, but the problem with it is that we can't use child model renderers with it. It can't generate those, and therefore we wouldn't be able to create something like this. Then we would have to keep in mind which rotation the panel has, depending on its size. Therefore we would have to rotate them differently. We would have to use different textures even, maybe. And after the break, which will be very soon, we'll also take a look on what we can do even further with having child models. It's going to be a segmented solar panel. So we're going to have a bigger one here, but it's going to have multiple segments, so when it's going to extract one segment at a time to sort of, when it retracts, it's going to get very small, but when it extracts, it's going to be very big. But like I said, that's after the break, so I'll see you in about 15 minutes.